So like I said, first thing we're going to do while we work on converting forms is we're going to take this form in standard form, and we're going to work on getting it into factored form. So let's write that equation down again. F of x equals x squared plus x minus 12. And really all that we need to do, number one, is factor the quadratic. Okay, just a reminder that when we're factoring, it's ax squared plus bx plus c. And I think most of us have been using boxes. I don't know that I'm going to say a specific way, but regardless, we should expect to find two numbers that add to b and multiply to a times c. And then from there, either use area model or use factor by grouping. Okay, so simply put, we're just factoring. Now, if we recognize a factoring shortcut, let's use those, right? I'm recognizing here that a is 1. So I can factor this very quickly after I find my two numbers that add to b and multiply to a times c. So numbers that add to b, which is 1, and multiply to, in this case, it's just c, right? Because a is 1, 1 times c is just c. That's why we're able to use this shortcut here. So multiply to negative 12. Our numbers are 4 and negative 3. The 4 has to be the positive numbers, so that way they add to a positive 1. And thus, that is going to be the numbers we use for our factors, giving us f of x equals x plus 4 times x minus 3. And boom. We are done converting this from standard form to factored form. So nothing new there. Really just need the factor. All right, now using that same equation, let's now take that equation and convert it into its vertex form. And in order for us to do that, again, just very simply put, we just need to find the vertex. Now, before we do that, I want to point out that in vertex form, just remember that your vertex form is f of x equals a x minus h squared plus k. This is the same a value that is in standard form. Okay, so let's make a note that the first thing we're going to do is just identify the a value. Yeah, I can zoom in a little bit. Okay, identify the a value. Then step 2, we're going to find x coordinate of vertex. Which we do by using negative b over 2a. And then step 3 will be find the y coordinate of vertex. And we do that by plugging x back into equation. Okay, and I'll give you all a sec to get caught up with writing that down. So again, this says vertex form, f of x equals a, x minus h squared plus k. That a value is the same a value that is in our standard form. So we want to identify that a value. Then our next task is finding the vertex. First using negative b over 2a, and then plugging that back into our equation to find the y. And we're going to work with that same equation of x squared plus x minus 12. All right, so step 1. Our a value is a positive 1, and that comes from the number in front of the x squared. Okay, if there's no number there, It's just a 1. Step 2, x equals negative b over 2a. So that's negative 1 over 2 times 1, which is negative 1/2. Which you could also write as a decimal as negative 0.5. And then step 3 is to find y. So we're going to find f of negative 0.5, which is negative 0.5 squared plus negative 0.5 minus 12. I'm just going to let the calculator do all that work for me. Again, your use of parentheses here are so important when we're squaring values. So I'm going to go negative 0.5 squared, and then plus a negative 0.5, and then minus 12. And I get f of negative 0.5 equals negative 12.25. Okay, and now that we have every single piece of information we need to write in vertex form, we just need to write the equation. Okay, so the equation is f of x equals our a value of 1. We actually don't need to write the 1 here, but I'll go ahead and do that just so that we know where that a value goes. And then it's x minus the x coordinate of the vertex. So it's a negative 0.5 as the x coordinate. So I'm going to say plus 0.5 and squared, and then minus 12.25. So really not doing anything new in terms of algebra from what we've been working on all week. Okay, it's just thinking about what parts do we need to be able to convert this equation from standard to vertex form. Okay. Any questions here? Okay. So we're going to now start with our quadratic in a vertex form, and we're going to work on taking that vertex form and converting it into either standard form and then eventually factored form. This one's going to be probably the most involved, meaning the most amount of steps. Okay, so our equation is starting in vertex form, and we're going to work on getting it into standard form. So step 1, and really the only step that we're going to do is we're going to multiply out the equation. Okay, or what's the best word there? Let's say use order of operations. Let's just say use order of operations. That's really all that we're doing. Okay, we're basically using this equation, and we're going to figure out what x minus 4 squared simplifies to be, and then multiply that by negative 2 and then plus 8. Okay, so remember that order of operations is PEMDAS. Okay, so we have parentheses, but there's never going to be anything that we need to simplify inside the parentheses. So we can basically skip the p, and we need to do the exponent first. Here. So when I take this equation, when I say the exponent, I'm referring to the x minus 4 squared. We need to square that entire term. So I'm going to do some side math with that, meaning I'm going to ignore the negative 2 and the plus 8 for now, and I'm only going to think about what this exponent works out to simplify to be. So I'm going to figure out what x minus 4 squared is. Remember that when we're squaring something, that means to take that term and multiply it by itself. So what a lot of students will do is they'll go, oh yeah, that's x squared, and then whatever negative 4 squared is. So they'd call it x squared plus 16, which you're getting a lot of those terms correct, but you're going to miss a very important piece of that. Because when we think about what needs to happen when we expand it out, we need to basically FOIL, right? And if you FOIL using boxes or have a method for that, we're going to end up getting a b term in the middle there. Okay, so that gives me x times x is x squared. Negative 4 times x is negative 4x. I get another negative 4 times x. And then negative 4 times negative 4 is 16. And then combining like terms, negative 4x and negative 4x makes that negative 8x plus 16. So x minus 4 squared equals x squared minus 8x plus 16. So now I'm going to rewrite the equation with that x minus 4 squared expanded out. So f of x equals negative 2, and then x squared minus 8x plus 16 plus 8. So all of this replace the x minus 4 squared in our equation. So the order of operations, we dealt with the exponent. The next thing is multiplication. So now we're going to multiply the a value or distribute it into that equation. So we'll distribute this negative 2. And I get negative 2x squared plus 16x minus 32. And then we still have that plus 8. And then the last thing we need to do, there's no division. There's either addition or subtraction, telling us to combine the constants. So the negative 32 and the 8. So it's negative 2x squared plus 16x and then minus 24. And we are all done. All right, so again, nothing new that we did algebraically, right? It's just keeping track of the order of operations and remembering that when we square the x minus 4, it needs to get expanded out and FOIL. Okay, you can't just simply square the x and the negative 4 and call that good. Okay, then go ahead and flip this over. And we'll probably, let's just do going from vertex form to factored form, and we'll save the next two for Monday. We'll split this lesson up across 2 days. That way I'm not rushing through to get the last going from factored form into the other forms. And I think even with this lesson, a lot of you might be able to figure out how to convert between forms without me even going over it. Okay, so the last thing we got, going from vertex form to factored form. I'm just going to write down that vertex form again, negative 2x minus 4 squared. And plus 8, plus 8. Okay, so there's really two routes we can take here. I don't know that one is any better than the other. So method 1, method 2. Okay, method 1 would be to first get equation into standard form. Okay, which we actually just did, right? That's what we had just worked on in the last example there, where that ended up being negative 2x squared plus 16x. And then minus 24. And then 2 would be factor the equation. I would probably recommend that method fact, I don't even know if I want to go over the second method. I'll still mention it. Okay, let's go ahead and factor this. And we'll factor it by finding two values that add to b, which is 16, multiplied to, what else could I do here to make the factoring easier? What'd you say? Simplify, what do you mean by that? Yeah, take out a greatest common factor. Okay, let's pretend that we don't see that. Okay, because so far we've been getting the a value to be a positive one quite often. So let's pretend that we don't recognize that, and instead we have to factor by grouping, okay, or use the boxes. So I didn't recognize there's a greatest common factor, so I am finding numbers that add to b and multiply to 48. Again, that 48 came from -2 times -24. And those numbers, (12 and 4), yep, are 12 and 4. And remember what those numbers do for us. Those numbers take our equation and split up the b term to be 12x and 4x. So now we have 1, 2, 3, 4 terms. We always need those 4 terms to be able to factor. So now we'll go ahead and use our area model. So -2x squared, 12x, 4x, and -24. Now with this a value being negative, I know that one of my dimensions here, when I figure out what needs to multiply to be -2x squared, one of them has to be a negative. It doesn't matter which one you make negative, it will determine what the other signs end up being here. Okay, so I'm going to let that be my negative. Then I'm going to just find greatest common factors. So -2x squared and 12x. For sure in x. And then I can take out, I already decided I want to make this positive, so I'll make this 2x. Now here's where we need to be careful and why greatest common factors, if we take it out originally, make this easier. My GCF of this first column is also a 2x. But if I take out a 2x here, then I'd have a -2x times 2x, making that -4x squared. So yes, 2x is the greatest common factor, but if I take out the 2x from that as well, it's not going to give me my correct factors. Okay, so if we did take out the GCF to begin with, we wouldn't have that issue. So I'm just going to leave that as an x because now 2x times -x gives me -2x squared. And I'm just going to use the multiplication to figure out the other dimensions here, where 2x times a positive 6 gives me this to be positive 12x. And then -x times a -4 makes that a positive 4x. And then -4 times 6 is -24. And thus our factored equation is -x plus 6 times 2x minus 4. And had you taken out the GCF, which it shows up for me in this factor of 2x minus 4, I could divide that out by 2 and make this even better by saying 2 (x plus 6) times x minus 2. Okay, so either one of these would work. Okay, let's stop there. We'll pick up and talk about the second method when I see you all on Monday. And then we'll work on going from factored form to standard and factored form to vertex form. Again, I bet a lot of you can figure it out, so it may not be something that you need me to go over before you try it on your homework. Okay?